Today we're going to be looking at lesson 7.5.11. And for this lesson, we're going to be focused on what are the rules when we're multiplying and dividing with positive and negative numbers. So the very first thing you're asked to do is to take a look at this equation, negative 27x equals negative 35. And notice it says without computing. Computing simply means without actually solving for the answer. So you don't have to find the real answer. Is the solution positive or negative? So the first thing we have to understand for this here is that negative 27x, okay, this simply means that we have 27 negative x's, okay? Or another way to look at it is that some number x, when we take negative 27 and we times it by a number, we don't know what number that is, so we're using x, is equal to negative 35. And so when they ask for the solution, they're saying, well, what is x? What is the number that we are trying to multiply negative 27 by to get negative 35? So if we know our multiplication rules, the rules are if we have a negative number and we multiply it by a positive number, we'll get a negative number, right? If x was also negative, that means we would be doing negative 27 times negative whatever number, and it would equal a positive number, not a negative. So without even having to do this, I know the answer has to be a positive number to make the answer stay negative. Okay, so we already know that. So this has to be positive. Now, are either of these two numbers solutions to the equation? So here, remember that a fraction is a number, right? But fractions are also the same thing as division. So when we see 35 divided by 27, that is the same thing as saying, or 35 27ths is 35 divided by 27, right? That's what we would be calculating here. For this one, we have negative 35 27ths. So again, we're trying to figure out here which are either of them a solution. So we have to figure out, will either of these work in this situation? So when I see this, first of all, I'm noticing both numbers 35 and 27 are here, right? I also know, so here's what I'm thinking on this. If I had to solve the problem, let's say 2x equals 6. All right. That's simply saying what number do I multiply 2 by to get 6? And if I were to solve that, I would use division, right? I would say, oh, well, 6 divided by 2 is the answer to x, right? And we know that that also equals 3. So the answer here is 3, right? 2 times 3 is 6. I can use this same idea to solve this problem, right? So it's the same setup. It's a number, in this case, negative 27 times x, right? And instead of 6, it equals negative 35. So if I wanted to solve for x, what I would have to do is I would take, well, let's see, instead of 6, I would take negative 35, right? And I would divide it by, well, instead of 2, like here, we would divide it by negative 27. And so I know if I'm dividing this, well, if I divide two numbers like this, well, it's going to equal a positive. So I actually know I could simplify this as 35 27ths because these two negatives, when we divide two negatives, we actually get a positive number. So it's the same thing as this. So I actually know that that can also be my response. Okay. So let's check this one out. It says fill in or find the missing value in the equations. We're doing kind of the same thing here, right? This little, it's called an asterisk. That is called a, that's multiplication in this case. So this is simply saying -3 times 4 equals what? Right? So -3 times 4, well, we know a negative times a positive is a negative, and 3 times 4 is 12. So this has to be -12. And so now they're saying, well, -3 times what equals +12. So again, when I look at this, I'm thinking, what do I multiply -3 by to get a +12? Well, again, I'm going to kind of use what we did in the warm-up here. I know I can divide this number, 12, divided by, or we could keep it as a fraction, -3 equals what? Well, first thing off, I see I'm dividing a positive and a negative, and I know that to get this positive, this has to be a negative. So my answer is going to be negative. And 12 divided by 3 is simply 4, right? So I know -3 times -4 is +12. So my answer is -4. Let's look at a little further down. On this one, we have 3 times what is 12. Well, I know to get a +12 over here, I've got to multiply a +3 by a +4. So that's going to be +4. For this one, they're saying what number times -4 is +12. So again, I know if I'm multiplying something by a negative, this number also has to be a negative, right? Because a negative times a negative is a positive. What do I multiply 4 by to get 12? Well, 3. So the answer, -3. And then here for E, it says what times -4 is -12. So again, so now I'm thinking, okay, I have a negative and this 4 is negative. So what do I multiply a -4 by? To get a -12, this is going to have to be a positive. So it's 3 times -4. So it's +3 on this one. Okay. So here it says rewrite the unknown factor problems, so B through E, as division problems. All right, and you're going to write those in here. What I'm going to do is write them up here next to them, which we kind of already did, right? So, well, for this one. So for here, we knew that this has to be a 4, and we knew it had to be negative because it was positive answer, right? So what we ended up doing is we really took 12, +12, and divided it by -3. So 12 divided by -3, we got a -4. For this one, what we really did is we took the +12, right? We divided it by a +3, and we got +4, right? For this one, oops, I'm going to erase this. We took +12, we divided it by -4, and we got -3. And over here, we did -12 divided by -4, and we ended up with a +3. Okay? So that's the division problems that we did. So we turn our multiplication into division. So complete the sentences, be prepared to explain your reasoning. The sign of a positive number divided by a positive number is always, so if we do a positive divided by a positive, the answer is positive, right? You've been doing positive divided by positive for a long time. For this one, the sign of a positive divided by a negative is always, well, let's go back here. a positive divided by a negative. Well, here's a positive number divided by a negative, and it's a -4, right? And we knew that because to multiply a negative you have to multiply by another negative to get a positive number. So no matter what, always, if you're dividing a positive and a negative, you get a negative. It's just like multiplication. So it's always going to be that way. So a negative divided by a positive is always, well, let's go back here and take a look if we did a negative divided by a positive. We didn't do a negative divided by a positive. However, let's consider this. No matter what, if we're taking, if we want a negative answer, we have to have a negative and a positive that we're multiplying together, right? So no matter what, if you are dividing a positive and a negative or a negative and a positive, the answer the answer is always going to have to be negative, right? Because to get if you're multiplying by a positive and you want a negative answer in multiplication, you have to multiply by negative. And finally, if you divide a negative by a negative, well, if we look at our last problem that we had done there, that was -12. So you're saying what times -4 is -12? Or I'm sorry, whoops. Yeah, that's right. Well, to figure this out, if you're taking a -12, you have to multiply a positive by this number here to get the negative. So if you've already got a negative number that you're multiplying by and you want a negative answer, you're going to have to multiply by a positive. And those are our answers. So we've found here that it actually works out exactly the same as multiplication. So now we're going to be using what we know to solve some problems here. So here we have Han and Claire, and they're walking towards each other at a constant rate. They meet up, and then they continue past each other, so that's where we're at now, so that they're then walking in the opposite direction. We'll call where they meet 0 and 0 feet, and then the time was 0 seconds. So here they're telling us Han's velocity is 4 feet per second. Claire's velocity is -5 feet per second. So I'm remembering that the velocity is simply saying how fast they're walking. So that's the number. But velocity includes the direction. So the positive shows that Han is walking towards the positives. And the negative here for Claire says that she's walking towards the negatives. Where is each person 10 seconds before they meet up? Okay. So when I do problems like this, one thing that I personally like to do is draw a table to try to understand my thinking here. So I know that 10 seconds before they meet is actually, we'll call that negative seconds. But here's what I would personally do. I'm going to have this, let's see, I'm going to do 2 tables. One is going to be for Han. Okay, so I know, and I'm just going to draw an XY chart here, a T chart, right? So and I say XY, I'm going to make this, let's say, here's their time, and then here is their distance. So I'll make that feet because that's what they're walking in. And I already know that 4 feet per second. So that means Hans at 1 second, right? He's at +4 because that's 1 feet per second. I know that Claire at 1 positive second, which I guess I need to make her chart. It's going to look the exact same, but I'm going to use her velocity instead. So time and feet. So I know that for Claire, at 1 positive second, that's after they've met up, she's actually already at -5 feet, right? Negative meaning she's going towards the negatives. So they're saying 10 seconds before they meet. So if the time is -10, right, that's before. So I'm thinking Claire is going to be over here, right? That's before they've met up. Han is going to be over here. So I know he's actually in the negatives, right? So, and for each second, he's 4 feet. So -10, right? And then I know to get here, I have to do times 4. So that means he's at -40 feet. And I know Claire, she's at -10, but I also know to get the feet, right, I have to do times -5. So she's at 50 positive feet, right? The reason I knew to do times 4 is because for every 1 second, Han is 4 feet. So that's -10 times 4. And Claire is -10 times -5 because she's at -5 feet per second. So Han is at -40 feet. Claire is at 50 feet. Okay. When is each person at the position -10 feet from the meeting place? Okay. So here I'm I'm thinking about this because I know Han is at, they're saying in this table, when is Han at 10? And same thing here. When is Claire at, -10? Sorry. When is Claire at -10? Okay. So basically, I'm knowing to solve these, I take their rate, right, times their time, and it's going to equal their distance, or in this case, feet, right? So I'm basically saying for Han, what times +4, because that's his rate, equals -10, right? So in this case, I know, well, that's a division problem, right? So I'm going to do -10 divided by +4. So my answer is -10 fourths, or I could simplify that. I could use decimals, or I could just know, okay, let's see, if I divide these by 2, I get 5 halves, which is also the same thing as -1.5, or 2.5, sorry. Okay. And then for Claire, I know hers is going to be something times -5 is -10. And I know that that's got to be a +2, because 2 times -5 is -10. So her answer is positive, his answer is negative. So -2.5 seconds. And notice I'm saying the time because it is time, and his is -2 seconds. I always answer the question with a label. Okay. Next. All right. Now we're looking at a water well that's been, it says a water well drilling rig has dug to a height of -10 feet. So a water well, that is like, for instance, I used to live in the country. I had a well. That's how I got my water. So somebody dug a hole down into the ground until it hit the water that was underground. And then that water gets pumped up to the house, right? So that's what's happening here. And so they're talking about the drilling rig, which is simply the machine that digs the hole, right? So I know that in this case, they're telling me that it's in 24 hours. Let's say this is 0. So this is going to be the ground, right? The surface of the earth. In 24 hours, the machine dug down to 60 feet below the surface. That's what the -60 means, and that took 24 hours. So it says, assuming that the rig drilled at a constant rate, meaning it's at the same speed, what was the height of the drill after 15 hours? Okay. So there's a lot of different ways you can do this. I, for instance, know that whatever this rate is, we don't know the rate of speed, right? But we do know that if we multiplied it by 24 hours, the rate, it gave us -60. right? So our question then is, what if we do that rate times 15? What's the amount that we're going to do, right? 15 hours. So we have to find that rate first. And I know that all I have to do for that is to go ahead and divide, right? So we'll find that rate. Again, this connects to our proportional relationships because we could put this into a table, find the COP. That's what we're talking about, right? So we know that rate times time is the distance, and the COP is the rate. We're saying, what do we multiply time by, right, to get the distance? And so to do this, we're going to do negative 60 divided by 24. So there's different ways you can do this. You can set this up as a regular division problem like this to get a decimal, right? That's one way. You could also solve this as a fraction, which in some ways that might actually be easier. They're kind of the same thing, but they're just slightly different. So for this one, I'm going to go ahead and I'm going to try to simplify this as a fraction. So I'm thinking to myself, how many times does 24 go into 60? I'm thinking if this was 20 times 3 is 60, so it's got to be 2 times, right? So I know that this is going to be equal to 2 wholes. And then let's see here. So let's see, how much do we have left over? So 24 times 2 is 48. So I'm going to take 60 and I'm going to subtract 48, right? Because that's what 2 wholes of 24 is. So when I subtract, I have to remember to borrow. So that's going to be 12. So I know 12, that's 2 and 12 24ths, or I happen to know that 12 is half of 24. So this is the same thing as 2 and a half. And then the only other thing I'm thinking of is, do I multiply by a positive or a negative to get this number here? I know it's a negative. So my rate is negative 2.5. So it's drilling down 2.5 feet every hour. If that's true, now we just have to figure out, well, what is that times 15 hours? So again, we're not using calculators here, so we have to solve this on our own. So I'm going to erase this work because we don't need this as of right now. But we do know we're going to be taking our 15, right, because we know the time, and we have to do 15 times 2.5, negative 2.5, actually. So what I'm going to do is just multiply those two first. There's lots of ways you can do that. I know students oftentimes, and personally, I like to do 15 over 1 because that's 15 written as a fraction. And then I'm going to turn this into a improper fraction. So that's the same thing as 2 times, 2 wholes, break them into halves. That gives me 4 halves are in this 2 wholes plus the extra half. So that's 5 halves. So I know 2.5 is the same as 5 halves. And now I just multiply. So I know this is 30 halves. That's not 30 halves because this is a 5, not a 2. I was wondering why that was working out weird. So let's see. 15 times 5 is what we really have to do, right? Because in multiplying fractions, we just multiply across. So 15 times 5 is 75. So I actually know this isn't 30 halves, it's 75 halves. And we can go ahead and simplify that to figure out, well, what is that actual distance? So 75 halves. Again, I'm going to now change it back in. We could leave it this way, but I like to actually see a mixed number. So I'm thinking, how many halves are in 75? Well, I know this goes in 3 times with 1 well, this is a 6. This is a 1 left. So 2 goes into 15 7 times with 1 left. So this is actually negative, because again, this was a negative times a positive. So it's negative 37 and a half feet is what happens. Okay. So now I can stick that in here, negative 37 and a half, or I'm just going to say 0.5. I'm going to use that because I know 0.5 is the same, and that would be feet. Okay. And then here it says if the rig has been running, constantly and is currently at a height of negative 147.5 feet, how long has it been going? Again, and I'm going to actually just erase all of this real quickly here just to give me a clear screen here. So now I basically know my rate is negative 2.5, right? Or we've been doing negative 5 halves. And we're saying negative 5 halves times what time equals negative 147.5. So basically, we are trying to figure out this is a division problem, right? So there's different ways you can do this division problem. I'm going to set mine up as fractions. So I would keep this, so I know I'm doing 100, let's see, 147 and a half is what that means, right? And actually, I'm going to turn this into a mixed number. So this may or may not be the most efficient way, but we'll try it. So a mixed number simply means I'm going to take these and turn 147 wholes into halves, right? So I know I have to multiply this by 2. So I know that that is 294 plus that extra one. So I know that this is negative 295 halves, right? And actually, I should have written that somewhere else. And we're going to divide it by negative 5 halves. So we said negative 295 halves divided by 5 halves. Okay, so this is where we have to remember how to do this. If we're dividing fractions, we actually flip this. So I know a lot of you like keep, change, flip. I just know that I'm taking negative 295 halves and I multiply it by 2/5. Okay, and then get the answer to that. All right, so in this case, I could multiply across. I'm personally going to know that I can cross cancel these. These are going to be ones. And so now I'm left with negative 295 fifths, which is a basic division problem. So 295 divided by 5 is going to be, let's see, that goes in 5 times. That's 25. 4 left. Bring it down. I know that that's going to be 59. So I also know that I was dividing a negative by negative, so I get a positive. So I know that this rig had been running for 59 hours. Okay. And then finally, we have to use this grid to plot the points, and we will do that. The way I can use the coordinate grid to show the drill's progress is to go ahead and just plot what is happening. So the first one shows negative 60 feet at 24 hours. So I'm literally going to find, well, this is the time, right? So we have hours on the top, or the X, and then here is the feet on the Y. So, and it's all showing negative 50, negative 100, and then the time is always positive. So for the first one, it's got to be 24 hours. So I know that's about a little less than halfway between 20 and 30. And then I also know, so that if this is negative 50 and this is negative 100, I know halfway between there is 75. So 60 is going to be a little bit half of that, half of the half. So this should show the progress for the first one. Whoops. The next part we saw was at 15 hours, it was at about negative 37.5. So I'm going to find 15 hours. So I know 15 is exactly between 10 and 20. And then negative 37.5. So negative 50, we know half is negative 25. So we know it's going to be about in here. Whoops. There we go. And then we also know negative 147.5 feet went with about 59 hours. So we're going to find almost 60 and then go down to negative 147.5. 100 to 150, so we know it's probably going to be somewhere in here. Okay, and so now we can see here's the progress, right? And it's actually making a straight line, and that's because this is, or it's close to a straight line, because this is in fact a proportional relationship. So it should be pretty close to a straight line. You can see there. All right, it's a little off, but it's pretty close. So that's a good thing. So explain the rules to divide and should say multiply positive and negative numbers as you understand them. So I know that when I multiply or divide a positive and a negative, that the answer will be negative. And I also know that if I multiply or divide, two positives or two negatives, that the answer will be positive. And that's it. That's how we divide